today we look at the manufacture of Portland cement. Generally, cement is a material which have got adhesive and cohesive properties. Therefore, we are talking of material that can be able to cause budding. And in our case here, because it's in civil engineering, we are concentrating on Portland cement, a cement which is made from calcareous material, calcium, and aggregaceous material, that is clay. So the raw materials that are used in the manufacture of cement, this is from limestone. Then we obtain we call the calcareous material, and from clay, we're talking of the aggregaceous material. And here, the clay, we get the silica, the alumina, and the iron. On the calcareous, this is the calcium, basically. So you can see there are two main components. Of course, this one you obtain through coring process. You obtain these materials, raw natural materials, through coring process, which are crushed together. Of course, it's a process. Now the crushed limestone and the shale clay are mixed and ground together, heated in a kiln to form what is referred to as a clinker. The temperatures are very high to cause clinkering or sintering, fusing together. And then once a clinker is formed, is crushed into a fine powder. Gypsum is added to aid crushing, as well as, of course, it reduces the temperature for crushing, as well as, of course, it will be, later on we'll see, it's used to reduce some properties of cement, like the setting time. So this is in general the simplified workflow, but we can look basically into the details a little bit further. So what happens is that there are two things that we want us to look at. The mixing process. The mixing can happen whether in the presence of water, what we call the wet process, or in the absence of the water, what we call the dry process, here at the mixing stage, right? And again, at the clinker here, the kiln, we want to mention some terminologies here. The temperatures are very high, around 1450 degrees centigrade. Something called clinkering or sintering happens, right? And then there is what I mentioned about the gypsum. We see what happens. But in general, this is the flow of how cement is made. So I have mentioned that once the materials are crushed, they are mixed, and I've said that there are two processes of mixing. It could be either in presence of water or in absence of water, what we refer to as the dry or the wet process. So let's start with the wet process. So what will happen is that the two materials, we have found that the raw materials are clay. Clay brings in the silica, okay, alumina, okay, or iron, and then chalk. This brings this is the limestone, so this brings in the calcium oxide. So you can see clay. And why would we go, before I proceed, why would we go for the wet process? This is where the percentage of the moisture in the raw materials is very high. From where you are mining them, the percentage in the moisture is very high. But for the dry process, as we are going to see in the next slide, is that this is where the raw materials are so hard that they do not disintegrate in water, or in cold country where if we use water, maybe freezing would occur when we have a shortage of water. But let's first stick with this the wet process. So we are saying the chalk is finely ground, broken up and dispersed in a wash mill. So this is when we have water, a wash mill. So the chalk will become in powder form, crushed and into powder form. Then water is added. The clay also will be broken up and mixed with water in a wash mill to create a clay slurry. So you see now the clay slurry comes and joins the chalk dispersed in powder, and these two now raw materials are in a molten form, or we can call the slurry. In the predetermined proportion, they are taken through screening. They are taken to the bleeding. Okay, and in this bleeding section, they are mixed mechanically in the storage tanks, and the sedimentation of the suspended solid is prevented by a bubbling air. Yeah, you don't want the suspended solids to settle at the bottom, so there is a bubbling of the air. And as a key, where we have the solid arrows, they show the flow of the process of manufacture of the materials, the raw materials, how they are flowing, while these arrows, they show the flow of air, which are not solid. Okay, and in this, once they are blended here, ensuring no sedimentation occur, is taken to the slurry tank. And here, what we do, we can take the sample to assess the proportion. Okay, Remember, we are making cement of a certain proportion because there are different types of cement based on the ratio of the mixture, whether of the calcium, whether, of course, the calcium oxide, the silica oxide, the alumina oxide. So in this tank, then we can do the proportioning. Before now, we can come, because here they are still in their separate, although they are mixed up, they have not fused, they have not become one. In the kiln, when we heat, this is when here now irreversible combination of the different constituents, the silicates and the calcium, silica, aluminates combined together permanently in an irreversible manner in the rotary kiln. So we have to ensure that we have obtained the right proportions in this slurry tank before we can take them to the kiln. Now, after the slurry, now we have obtained the desired proportion, of course. This slurry now passes through the rotary kiln, and the rotary kiln is slightly inclined, as you can see. It's at a certain degree, it's not purely horizontal, so that the slurry can flow slowly by gravity. And from the other side, hot air, okay, whether from power coal, oil, or natural gas, is blown, hot air blast, like this, from the lower head of the kiln. This is the lower head, this is the upper head. And you see, as it rises up, it meets with the slurry which is going downwards. At the bottom head here, the temperatures reaches even up to as high as 1450 degrees. Of course, the rotary kiln, we are saying this is a large refractory rind steel cylinder. Okay, these temperatures are very high. So refractory, this refractory, of course, uses materials which are resistant to decomposition by either heat, pressure, or chemical attacks, and maintains its strength and form at very high temperature. Okay. So this is another topic for another day, talking about the ceramics. But what we are saying is that this is not just a steel kiln, it's lined with those ceramics. It's a refractory, so that it does not decompose due to this high temperature. So at this upper end, the air, as the slurry moves downwards, first the water is driven off and carbon dioxide is liberated. So at these temperatures, maybe if this, assuming it was 0, so as it continues rises to 100, 200, water vaporizes and carbon dioxide is liberated. Then material becomes dry, and a series of chemical reactions happens in this rotary kiln. At the hottest part, about 20 to 30% of the material becomes liquid. So we have liquid lime. Now this liquid, lime, silica, and alumina will recombine. So you see, lime, of course, calcium, silica, and alumina combines. They were separate. Calcium was from chalk, silica and alumina was from clay. But now you're seeing at this very high temperature, they recombine and they fuse into balls. They fuse into small balls of between 3 to 25 millimeters, forming what is called a clinker. So at the lower end now, the clinker flows. So this is a continuation here. On the rotary kiln, to the lower end, the clinker comes out as small, dark colored or black colored pellets. And now from here, the second part from the rotary kiln here, going all the way now to the production, see, is similar whether you are wet or dry process. So let's finish the process here, and then I can mention something about the dry process on the upper end. So once we have this clinker, okay, it's allowed to cool, and then you see these are pellets, but the cement that we are getting here, you can see these are either bulk storage, bulk transport, where you have seen these big tankers which transport cement in bulk. So these are hopper loading, or we can be packaging it in bags. Okay, this is a packaging section in the packaging plant. This is a cement silo. This is a storage of the cement. So before we get cement, remember here from the rotary kiln, we have obtained clinker in pellet form. So we need to grind it to very high degree of fineness. Before we do that, we add gypsum. Gypsum is hydrated calcium sulfate. Calcium sulfate, which is hydrated. And first, the gypsum acts as a flux material by reducing the heat required for, okay, not the calcium. Oh, sorry, that was okay. I'll mention about that later on. But for calcium, this one will be required later on. I'm going to mention about that. That is required to reduce or to control the setting of cement. Now, this after you have add some gypsum, then the clinker and the gypsum are ground. They are interground into very fine powder, and what we end up with gypsum plus the clinker which is calcium silicate aluminate, of course, plus other components which might have been in the raw materials. But remember, in the slurry tank we had to control the proportioning. Now what you grind and the end product is what is referred to as cement. We are going to see later on what are the actual composition of cement. But before then, I need to mention about the dry process. So the dry process, we say if the materials cannot disintegrate in water, or we have a shortage of water needed for mixing, or in a very cold country where we don't want to take the risk of using water, which can cause if freezing occurs. So in that case, the mixing is done in once you grind, of course, the limestone in a crusher, the shale, which is the clay, you grind it. So the mixing is done aided by air. Okay, so when you bring them here in the blending, instead of adding water, ball mill, of course, ball mill is a grinding place, and then or grinding chamber. The blending here is aided by air. Okay, so the materials are crushed, fed into the correct proportion in the grinding mill, where they are dried and reduced in size to a fine powder. The dry powder here is called the raw mill. Raw mill. This one. And of course, now raw mill style. It's then pumped to a blending silo. So this is where we do the blending. And final adjustment is made. Again, we have to do the adjustment of the component because before they react permanently. Okay, based on the type of cement that we want to manufacture. So to obtain a uniform blade, the raw mill is blended in the silo, usually by means of compressed air. Okay, by the means of compressed air. So we don't have water, so we are using compressed air to mix. Now the blended mill will be served into a rotating disc, which is called the granulator, and the water, maybe small water weighing about 12% of meal being added at the same time. So the water is not aiding in the mixing, but it's here when at the blending, at the granulator, so that we can be able to form hard pellets of about 15 millimeter in size. So the erythro amount of water that is added, the erythro amount is to aid in formation of pellets. Of course, these pellets are baked hard. Of course, in a preheating, we do the preheating, and the end product, of course, now this pellet is the clinker. Okay, we have now the pellet is what we are referring to the clinker, and the process now is this happened in the rotary kiln here, and the process now continues just like what we have seen in the wet process. So you see, this part is the same as in the wet process. From the wet process, we add gypsum in a ball mill. They are ground together to form now what is called the cement. So the process is the same of grinding, just as have been mentioned earlier. So the cool clinker, which is black in nature, is interground with gypsum in order to prevent flash setting as well as facilitate grinding. I was saying the gypsum will facilitate in the grinding process of cement. So this is a composition of the cement that will be produced, specifically Portland cement. And Portland is just a name given after the original cement, which was made in Portland, England, made from a Portland stone. But even if in your locality you are not talking of that stone, we are talking of cement having that properties as that initial cement which was made. So you see, we have the calcium silicate. The calcium silicate are two types: the tricalcium silicate, the calcium silicate. And then we have two forms of aluminate: tricalcium aluminate and tetracalcium aluminoferrite. Ferrite, of course, because of the iron. This is the oxide in full name, but here we are just using the abbreviation. In engineering, we allow this abbreviation, and you see the biggest proportion is tricalcium silicate, followed by dicalcium silicate, and of course these are in equal proportion the aluminate. Of course, if you add this, will come to 95% because 5% is taken by a gypsum. Okay. Later on, in another video, we are going to see what is the contribution of either of these compounds in the properties of cement. So stay tuned and look out for another video. Subscribe, share, like this video for more learning experience. Thank you for your time. Bye-bye.